So let's do a problem. In a centrifugal compressor, air enters at 30 degrees centigrade and leaves at 130 degrees centigrade. The air is compressed through a pressure ratio of 2.5. Calculate the isentropic efficiency and power required by the compressor if 25 kg of air is compressed per minute. Take Cp equal to 1 kJ per kilogram Kelvin and Cv equal to 0.716 kJ per kilogram Kelvin for air. So given air enters T1 equal to 30 degrees centigrade, that is 30 plus 273, so that is 303 Kelvin, and leaves at 130 degrees centigrade, so T2 equal to 130 plus 273, that is equal to 403 Kelvin. Air is compressed through a pressure ratio 2.5. Pressure ratio given is 2.5. We have to find the isentropic efficiency and the power required if m dot is 25 kg of air per minute. So power required in the expression power equal to m dot Cp delta T. So m dot Cp T2 minus T1. So Cp is given, m dot is 25 kg of air is compressed per minute, so 25 by 60 kg per second, so that is equal to 25 by 60 into Cp is 1 into T2 minus T1 is 403 minus 303, so that is equal to 41.67. Unit will be in, so within the unit kilogram per second into 1 in the other Cp unit kilojoule per kilogram Kelvin into delta T unit Kelvin. So this K and this K will get cancelled, kilogram and kilogram will get cancelled, so kilojoule per second is kilowatt. So unit is 41.67 kilowatt is the answer, the first part. Now they have also asked us to find the isentropic efficiency. So we will draw a TS diagram. TS, so let it be 1, this is be 2s and this be 2. So isentropic efficiency equal to T2s minus T1 by T2 minus T1. So T2 T1 is known, but T2s is not known, but we know that T2s by T1 equal to P2 by P1 power gamma minus 1 by gamma. So pressure ratio is given. Pressure ratio is 2.5 raised to gamma minus 1 by gamma. So value of gamma is equal to Cp by Cv. Cp by Cv, so it is 1 by 0.716, we will get 1.4. So that is equal to 2.5 raised to 1.4 minus 1 is 0.4 divided by 1.4. So we get T2s equal to T2s by T1 equal to 2.5 whole raised to 0.4 by 1.4, or T2s is 393.67 Kelvin. So T2s getting, so substituting in this we have 393.67 minus T1 is 303 by T2 is 403 minus 303, we get the value as 90.67%. So next question, a centrifugal compressor has an impeller tip speed of 360 meter per second. So determine the absolute Mach number of the flow leaving the radial vanes of the impeller when the radial component of velocity at impeller exit is 30 meter per second and the slip factor is 0.90. Power input factor is 1. Given that flow area at impeller exit is 0.1 meter square and the isentropic efficiency of the impeller is 90%. Determine the mass flow rate. Inlet stagnation temperature and pressure are 300 Kelvin and 1000 kilonewton per meter square. R value is given 287 joule per kilogram Kelvin and gamma equal to 1.4. So when we read this question, we know that determine the absolute Mach number of the flow leaving the radial vanes ആണെന്ന് തന്നിട്ടുണ്ട്. So once we will draw the exit velocity triangle. So exit velocity triangle will look like this. Radial vanes, so this will be U2, so this will be VR2 equal to VF2 and this will be V2 with this angle as beta 2, so beta 2 equal to 90. So has an impeller tip speed of 360 meter per second. So we have given U equal to 360 meter per second and in velocity at impeller, radial component of velocity at impeller exit. So VR2 radial component VR2 is 360 VR2 is 30 meter per second. So these are the values which are given. So from this velocity triangle we know that V2 equal to square root of 360 square plus 30 square. So this is known, this is known. So that is equal to 361.247 meter per second. Now we have to find the Mach number. Mach number is flow velocity at the exit, flow velocity by velocity of the sound. So that is equal to V2 by root of gamma R T2. So gamma is given, R is given, but V2 we have calculated, but we don't know T2. So we have to find T2. So but we know that T01 equal to T1 plus V1 square by 2 Cp. Similarly T02 equal to T2 plus V2 square by 2 Cp. So from here if we can find T2 we can substitute it here and we can get the Mach number. So to get T2 we know we need T02, so T02, but we know that the pressure ratio P02 by P01 is equal to psi sigma U2 square eta by Cp T01 plus 1 whole raised to gamma by gamma minus 1, which we have derived recently. Substituting, that is equal to psi is 1 sigma, we will see. Power input factor is 1, slip factor is 0.90, so into slip factor is 0.90. U2 we have already it is already given 360 square. Efficiency is given as 90%, so 0.90 by Cp is given 1005 and T01 is given. Inlet stagnation temperature and pressure are 300 Kelvin and 1000. So T01 and P01 are given. So T01 is 300 plus 1 whole raised to gamma by gamma minus 1 is 1.4 by 1.4 minus 1 is 0.4. So So if we substitute, we get 2.845. This is the P02 by P01. Therefore P02 is 2.845 by 8 times P01. Now from isentropic relationship, so 0, 1, 2, 0, 2s, and this is 0, 2. We have T02s by T01 equal to P02 by P01, where this pressure is P02 and this is P01, whole power gamma minus 1 by gamma. So that is equal, therefore T02s equal to T01 is given as 300 into P02 by P01 is 2.845 whole raised to 0.4 by 1.4. So we get T02s as 404.45 Kelvin. T02s. Now from here efficiency is equal to T02s minus T01 by T02 minus T01, and that value is given as 90%. So substituting T02s from here, 404.45 minus T01 is 300 by T02 we have to find out, minus 300 equal to 0.9. So therefore we get, therefore simplifying, we got T02 equal to 416.06 Kelvin. T02 കിട്ടി. ഇനി ഈ T02 എടുത്തിട്ട് ഇവിടെ ഇട്ട് കഴിഞ്ഞാൽ we will get T2. So we will write it again here. T02 416.06 equal to T2 plus 361.247. 361 അത് V2 square by 2 CP, 2 into 1005. So ഇതിൽ നിന്ന് നമുക്ക് T2 നമുക്ക് കിട്ടും. T2 is equal to 351.09 Kelvin. So now we have found out T2. So that was our aim. So once T2 is obtained, we can find out the Mach number. Mach number M equal to flow velocity is 361.247, which is V2 by root of 1.4 gamma R into T2, 351.09, and we get the value as 0.962 is the value. First part is done. Second part is to find the mass flow rate. So mass flow rate is equal to rho 2 A2 VF2. So we have to find P2. Rho 2 will get from this equation, P2 equal to rho 2 R T2. So we don't know P2. So T02 by T2 equal to P02 by P2 whole power gamma minus 1 by gamma. So T02 is 416.044. T02 by T2 we have found here. T02 416, T2 351 by 351.09 whole raised to 1.5 by 0.4 equal to P02 by P2 or P2 equal to P02. Simplifying this, we get P02 by 1.81, that is equal to 2.845 into 100 by 1.81, that is equal to 157.06 kilonewton per meter square. So P2 is no P2 is 157.06 equal to rho 2 into R into T2. Rho 2 R 351.09. From here we can get rho 2 as 1.558 kilogram per meter cube. Rho 2 R T2 already നമ്മൾ കണ്ടുപിടിച്ചു 351.09. rho 2 കിട്ടി. So therefore mass flow rate is 1.558 into area into VF 30. So ഇതിൻ്റെ യൂണിറ്റ് എന്ന് പറഞ്ഞാൽ കിലോഗ്രാം പെർ മീറ്റർ ക്യൂബ് ഇൻറ്റു മീറ്റർ സ്ക്വയർ ഇൻറ്റു meter per second. So we get the value in kilogram per second. So that is 4.674 kilogram per second.